Welcome to the Fusion Note, a weekly dose of breakthroughs, curiosity, and connection. Because the future's better when we build it together. Today, we're diving deep, really deep, into something our sources are calling humanity's secret threshold. Yeah, it's this idea that we're at a point where, the biggest mysteries, like consciousness itself, are bumping right up against these incredible leaps in technology.
Right, like quantum computing, AI.
Exactly. And also huge shifts in health. So our mission today is to try and pull together all this knowledge, this flood of information.
And find maybe the core instructions, what you need for navigating what some are calling the arc of redemption.
The arc of redemption. It sounds dramatic, but maybe it is.
Well, it's a massive task, isn't it? You've got physics, biology, AI, philosophy, all these fields, and we're looking for that connecting thread.
A common denominator.
Yeah, one source called the minimum viable consciousness.
Minimum viable consciousness. What does that mean exactly?
It's not about, instant enlightenment. It's more about finding that essential level of awareness, of understanding.
That lets us pivot
Yeah,
as a species.
precisely. Can we actually use these powerful new tools and ideas to transform ourselves, our societies, fast enough? Or do we trip over our own feet?
Stumble into self-destruction. The stakes feel pretty high.
They are. That's really what this deep dive is about, exploring.
Okay, so let's start with that core mystery.
Yeah.
Consciousness. For so long, the standard view in neuroscience was basically it's just brain chemistry, right? A byproduct.
Pretty much the dominant view, yeah. But that's really being challenged now, especially from physics and, interestingly, philosophy, too.
Suggesting it's something more fundamental.
Exactly. And our sources map out this really fascinating kind of three-way conversation happening right now.
It's amazing how far scientists are willing to push the boundaries now, trying to connect quantum mechanics to us.
Yeah.
The subjective experience.
Absolutely. Take the quantum foundations idea. Specifically, the OR theory orchestrated objective reduction.
That's Sir Roger Penrose and Stuart Hameroff.
Right. Penrose, the physicist, Hameroff, the anesthesiologist, and their idea is pretty radical.
That the brain is doing something completely unexpected with quantum physics.
They argue it's actively using quantum gravity effects, that consciousness isn't just signals firing between neurons, but it actually comes from the collapse of quantum states.
The collapse. Like when a quantum possibility becomes a definite reality.
And they think this happens with qubits, quantum bits, inside these tiny structures in our neurons called microtubules. They're like the cell's scaffolding.
Okay, so let me see if I get this. A neuron is active. These microtubules go into a quantum superposition state.
Briefly, yes.
And when that state collapses back to normal, that process creates little flickers of proto-consciousness.
That's the idea. Blips of proto-consciousness. But here's where it gets really wild.
There's more.
Penrose's math suggests this collapse is linked to the fundamental fabric of space-time itself, which means the correlations, the information from that collapse, might not be strictly bound by our normal sense of time. It opens the door to retrocausal effects.
Wait, retrocausal, like influencing the past.
Or at least information behaving in ways that seem like particles are jumping backward in time relative to their entanglement. It's mind-bending stuff. It suggests the universe itself might have a mechanism for generating observers, not just brains.
Okay, that is a massive claim. Quantum effects outside the usual flow of time, influencing things backward. It completely changes how you think about the brain's role.
Definitely, but that's just one perspective in this dialogue.
Right, so Orchard puts consciousness in the quantum hardware inside the brain. What's the next idea?
Well, another theory, quantum panpsychism, takes a different tack. It suggests consciousness isn't made by the brain, but it's a fundamental property of the universe itself, like mass or spin.
This is Federico Faggin's idea, the physicist.
Yes. He argues every quantum field is inherently a conscious agent.
Whoa! So we are fields, we are not the body. That's his quote, isn't it?
It is. In this view, the body isn't the generator of consciousness.
It's more like a receiver, an interface.
Kind of like a complex drone, as he puts it, operated by this deeper underlying field of awareness. And this, he argues, helps explain qualia.
Qualia. That's the term for our subjective experiences, right?
Yeah.
Like the redness of red or the taste of coffee.
Yeah.
Stuff that feels private and unique to me.
Exactly. That raw feeling of experience. Faggin says these qualia are pure, uncopyable quantum states. You can't break them down into just physics equations because they are the fundamental reality that physics describes.
So the brain acts like a filter, tuning into these universal conscious states and giving us our localized experience.
That's the gist of it, a very different picture from ORCH or R.
Okay, so we've got consciousness from quantum collapse inside neurons, OR, and consciousness as a fundamental field the brain tunes into, panpsychism. What's the third angle? Emergent spirituality.
Right. This perspective from thinkers like Tim Freke suggests consciousness, or at least the qualities we associate with it, like love, meaning, intention, weren't there at the Big Bang.
They weren't inputs.
No, they argue these things emerged. They developed and complexified over billions of years of evolution. They weren't present in basic physics or early biology.
So evolution isn't just creating complex bodies, it's actually building consciousness itself. The soul dimension, as they call it.
Exactly. It's like the universe is slowly waking up to itself through the process of evolution. These spiritual qualities are real, but they are achievements of complexity, not starting points.
Interesting. So 3 very different ideas about where consciousness comes from. But what strikes me is the common thread you mentioned earlier.
The urgency.
Yeah. One source even referenced, surprisingly, a Dan Brown novel, saying many scientists now feel our old model of consciousness is just broken.
Obsolete. There's a strong feeling we're right at a threshold moment, that a new understanding of mind is not just possible, but necessary. And that threshold isn't just philosophical speculation. Technology is forcing the issue, you know? The tools we're building are changing everything.
Which connects directly to that Google announcement, right? Quantum echoes.
Absolutely. This feels like a really significant leap. They used their Willow quantum chip.
And got results that just blow classical computers out of the water.
The numbers are pretty staggering. A 13,000 times speed advantage over today's top supercomputers for a specific, complex simulation task.
13,000 times.
Yeah.
That's hard to even grasp. It's not just a bit faster.
No, it's a different league. And it has immediate practical uses. This isn't just theoretical anymore.
So what does that kind of speed actually do for us? Why is it such a big deal beyond the number?
Well, it drastically speeds up our ability to solve really hard problems, especially in chemistry and material science. Think about designing new drugs or discovering new materials with specific properties.
Things that classical computers struggle with.
Terribly. Simulating how even a few atoms interact is incredibly complex for them. They just drown in possibilities. But this quantum echoes technique, it simulates quantum systems by sort of echoing quantum states forward and backward within the chip.
Echoing them, how does that help?
It lets them extract deep information about the system's behavior, modeling things like how proteins fold or molecules bond way, way faster. This could revolutionize how we find new medicines or create advanced materials.
Okay, so that's the incredible acceleration. But that power, that speed, it brings risks, doesn't it? Which leads us to the other side of the coin. The superintelligence moratorium.
Exactly. It's the essential check and balance, isn't it? This open letter pushed by the Future of Life Institute.
Calling for a pause on building ASI, artificial superintelligence.
Yeah, a pause on training AI systems more powerful than, say, GPT-4 until we can be sure we have robust safety protocols in place. They're talking about serious existential risks.
Like what? Loss of control.
Loss of control, yeah. Deep economic disruption, maybe undermining democracy, even potential species-level threats if ASI goals aren't perfectly aligned with ours.
And some really big names signed it. AI pioneers like Bengio and Hinton, tech figures like Wozniak.
It shows how seriously some experts are taking this, and public opinion seems concerned too. One poll said 64% of Americans support a pause.
The big players didn't sign, did they? OpenAI? Google?
No, and that's the catch. It highlights a real divide. The moratorium is a powerful statement, a warning flare. But without buy-in from the leading labs, it might remain more aspirational than operational.
So we have this race forward in capability and this urgent call to tap the brakes. That tension feels very real.
It is, and you see it even in smaller projects, like Reflect Orbital's space mirrors.
Space mirrors, what's that about?
Well, it sounds kind of sci-fi, but the goal is pretty down to earth. They plan to launch thousands of these large mirrors, like 60 feet across.
Thousands. Into orbit.
Into low Earth orbit. The idea is to reflect sunlight back down to specific spots on Earth.
Why? To what? Extend daylight.
Basically, yeah. Provide continuous solar power for things like remote agriculture or disaster relief. A novel clean energy idea.
That sounds potentially useful. But I sense a but coming.
There's always a but, isn't there? Astronomers and environmental groups are raising red flags. Big ones.
Light pollution.
Massive light pollution. Thousands of bright objects crisscrossing the night sky could wreck ground-based astronomy and potentially disrupt nocturnal wildlife in ways we don't fully understand yet.
So even a well-intentioned energy solution creates new problems. It really shows how every powerful new capability forces difficult choices.
Every single one. There are no easy answers at this threshold.
Okay, let's shift focus a bit, bring it down to maybe more immediate human impacts. Health breakthroughs. These always feel so tangible.
They really do, and there's some amazing stuff happening.
I wanted to start with that low-cost cancer therapy from UT Austin, using LEDs.
Yeah, this is a really clever application of physics. They combine these tiny, tiny things called tin oxide nanoflakes
Nanoflakes.
with just simple near-infrared LED light. The light heats up the flakes, but only the flakes, and they position these flakes right next to cancer cells.
So the heat targets the cancer directly.
Exactly. And the results in the lab are pretty remarkable. They reported killing up to 92% of skin cancer cells and about half of colorectal cancer cells in just 30 minutes.
Wow. And crucially, it didn't harm the healthy cells nearby.
That's the key benefit. It's targeted. And because it uses low-cost LEDs and doesn't generate a lot of heat overall, the potential is huge.
Like making treatment more accessible.
Yeah, they're thinking about portable devices for skin cancers you could potentially use at home, or even tiny implants to deliver the light therapy deeper inside the body for other tumors. It could be a game changer for affordability and access.
That's incredible. Okay, so from treatment to detection, the multi-cancer blood tests are making waves too. Gallery, right?
Right, the Gallery test developed by Grail. The Pathfinder 2 trial results were really interesting. They tested about 36,000 adults.
And what did they find? How well did it work?
The sensitivity was around 40%, meaning it caught cancer in about 4 out of 10 people who actually had it. Now, that number needs to improve, but here's a really important part.
Okay.
Over half the cancers it did find were at stage I or 2, really early stages.
When treatment is most likely to work.
Exactly. And get this, 75%, 3/4 of the cancers it detected were types we don't currently have routine screening for.
Like pancreatic, liver cancer, ovarian.
Those really deadly ones that are often caught too late. Finding those early could make a massive difference in survival rates.
That's huge potential. What about false positives?
That's always a concern with screening. The positive predictive value, or PPV, was around 62%, which means if you got a positive result, there was a pretty good chance, about 62%, that you actually had cancer. Still needs refinement, and long-term outcome data is crucial, but it's a very promising direction.
Definitely one to watch. And then there's the microchip restored site. This sounds like something out of science fiction.
It really does, but it's happening. This is focused on age-related macular degeneration, AMD, a major cause of blindness.
What does the microchip do?
Researchers created this tiny implant, just 2 millimeters square, that sits on the retina. It basically acts like artificial photoreceptor cells.
Replacing the damaged ones in AMD.
Right. It takes the incoming light and converts it directly into electrical signals the brain can understand and interpret as vision.
It works. People could actually see again.
Partially, yes. Participants who were functionally blind regained enough vision to actually read lines of text, identify shapes. It's a profound step forward for neuroimplants, restoring a lost sense.
Just incredible. The integration of tech and biology.
And that kind of biological modeling and intervention is just accelerating everywhere. We also saw sources mentioning nucleus genomics and their AI models.
For embryo screening.
Yeah, Origin AI.
Yeah.
Trained on millions of genomes, aiming to predict and help select embryos with a significantly lower risk, like over 50% lower, of developing major diseases later in life.
Wow. Huge potential health benefits there. But that also brings up some big ethical questions again, doesn't it? About designing humans.
Absolutely. Every one of these breakthroughs forces us to confront those deeper questions about who we are and what we want to become.
Which brings us back to where we started, really. That idea of minimum viable consciousness. We've seen the sheer power we're developing.
Quantum echoes, gene editing, AI.
The ability to restore sight, maybe even design life. So this arc of redemption idea seems to hinge on how we choose to use all this, right?
Wow.
Our conscious intent.
Exactly. And it forces us to think more broadly about consciousness itself, like the Animal Consciousness Declaration that came out recently.
Right, that was fascinating, including insects, crabs, octopuses.
Cephalopods, crustaceans, yeah. Formally recognizing that complex awareness might be far more widespread in the animal kingdom than we used to think.
So maybe consciousness isn't just this uniquely human thing. Maybe the universe is, I don't know, teeming with it in different forms.
That seems to be the direction things are pointing. We're just one type of aware agent among many.
And as we get better at understanding these other minds and the universe itself, there's this idea from Andrew Hessel that the next big step isn't just reading life's code, but writing it.
Yeah, Hessel co-founded the Human Genome Project, right? His point is crucial. Sequencing the genome was step one. Step two is getting really good at synthesizing whole genomes, designing life from the ground up, cheaply and reliably.
That capability, designing biology, it's almost unimaginable power.
It is, whether it's for making targeted LED therapy implants or creating new food sources or things we haven't even thought of yet. It puts world-changing tools directly in our hands, collectively.
So intent becomes everything. The sources seem to suggest this arc of redemption is about making conscious choices, choosing, say, cooperation over raw competition with these powers.
Choosing to build things that help, rather than just debating or fearing the possibilities. Maybe choosing connection, even love, over fear as the driving principle.
Placing our intent firmly on positive transformation.
There's a really nice synthesis of this in the Fourth Way teachings. It talks about the ark builders of our time.
Ark builders.
Yeah.
Like Noah's Ark.
Sort of metaphorically, the idea is these people aren't trying to stop the flood, fight the inevitable changes or seize power. They're just quietly doing the work.
Building their ark. What kind of work?
Inner work, understanding themselves, and outer work, building concrete solutions, connecting ideas. They operate with this trust that consciousness itself has an intelligence, a direction, and that every connection made, every bridge built between different ways of seeing the world, it adds something vital to the whole.
Every cure developed, every quantum puzzle piece figured out, every effort to understand another being, it all contributes to steering us through this.
That seems to be the underlying message. That building those bridges, making those connections, is the transformative act needed to navigate this secret threshold we're facing.
We have to trust the process of trying, of building.
Yeah. Trust the act of reaching out and connecting. #tag outro.
Wow. Okay, what a deep dive that was. We covered so much ground. From those competing, mind-bending theories about consciousness, the secret threshold.
Quantum collapse, panpsychism, emergence. This feeling that the old scientific model just isn't enough anymore.
Right. Then the sheer speed of tech with Google's quantum echoes, and the flip side, the urgent need for caution with the superintelligence moratorium.
And those incredible health breakthroughs, low-cost LED cancer therapy, the potential of multi-cancer blood tests, and actually restoring sight with microchips.
It really feels like we're standing at a crossroads.
It does. And if we start by asking about that minimum viable consciousness, maybe the place to end is with a question for you, the listener.
Okay.
What if the point isn't really about finding the one single correct theory of consciousness, or the one perfect technological fix for everything?
What if it's simpler? Or maybe harder?
What if the real task, the real adventure, is just to participate, to engage fully in this unfolding process of awareness itself? And to trust that taking the next step, that next leap of faith on the staircase, is always the right move.
Just keep climbing, keep engaging, keep building those bridges. That's a really powerful thought to end on. Thank you for joining us on this exploration. Keep thinking about these ideas, keep building, and we'll catch you next week on The Fusion Note.